Welcome to the second lesson on organic chemistry. We're going to be looking at the homologous series. We're going to start with the alkanes, all right? There are different types of homologous series: the alkanes, the alkenes, the alkynes, the haloalkanes, up until the carboxylic acids, all right? And we're going to be looking at the general formula, the functional group, and then we're going to be giving examples of the structural formula as well as the IUPAC name, all right? The IUPAC name simply means the international way of naming compounds, the international way of naming organic compounds, all right? That is the IUPAC name. It is a universal way of naming compounds, organic compounds specifically, all right? So let us look at the first homologous series. The first homologous series is, of course, the alkanes. We're going to be looking at the alkanes here. Now, the general formula for the alkanes is CnH2n plus 2. Now, this general formula, you need to memorize it for the exams because it is possible that they ask you about this general formula in the exam. So you need to know it by heart. And the functional group, all right? So it is only the carbon bonded to the hydrogen and the carbon single bonds. Okay, that is the functional group. Let us look at the example of the structural formula. The structural formula shows the structure, how this compound is. Okay, now look at this part here, the first homologous series, the alkanes. So the most important thing here is that they end with ANE. And the second most important thing is the general formula itself. So let's make the first example of an alkane below. Okay, let's look at the first example of an alkane below. Let's talk about the methane. When we count, remember in the previous lesson we said meth here. Meth means one carbon atom, all right? And then the ane, look at this ane here, the ending part, the last part, which is the ane, makes it an alkane. So how do you see an alkane? You see it with the ending ANE. That's how you identify that this is an alkane. And then let's look at the structural formula of this. So let me highlight this information. The meth, so this part, meth, means one carbon atom, all right? And how about the ANE? Remember, it tells you that this is an alkane. It tells you that this is an alkane here. The ANE. What does it tell me? It tells me that this is an alkane. Tells me that this is an alkane. This is an alkane. So the ANE tells me that this is an alkane, all right? Now let's look at the structural formula of this, all right? Let's look at the structural formula. Because remember we said meth means one carbon. So let's look at this carbon atom. We have only one carbon, right? Let's look at this. So it's one carbon. Can you see that? But then remember, this carbon must be bonded to the hydrogen atoms. So this carbon will be bonded to the first hydrogen there. And then the carbon, remember, the most important part of the carbon, what makes the carbon so special is that it can form a maximum of 4 bonds around it. So here we have got only one hydrogen atom. Let's put the other hydrogen atom. Look at this. The second hydrogen atom. This is the third hydrogen atom, all right? Let's put the fourth hydrogen atom there. So this will be the fourth hydrogen atom. So can you see that this now has a maximum of 4 bonds around it? And because it is methane, meth, the first part, which is the prefix, all right, meth means one carbon. So I'm only having one carbon atom here. Hence, it will be called methane. We are going to end with the suffix ANE. That is the suffix. Remember, in English, we've got the prefix and the suffix. So the prefix is the first part, which is the meth. And then the suffix will be the ANE, all right? That will be the suffix, all right? So this is methane. Methane because it has only one carbon atom. Okay, that's how we name this thing here. Now, let's look at the second example, all right? When we're looking at the 2 carbon atoms, all right? Remember, 2 carbon atoms means if, okay? Remember we said if. So let's look at ethane. Let's look at ethane. If means 2, all right? So we're going to have here 2 carbon atoms. That's what we're going to have. 2 carbon atoms, all right? But how about the ane? Remember, the ane tells you about the alkane, that this is an alkane indeed. This is an alkane, right? The ane tells you that this is an alkane. This is the first homologous series that we are dealing with here, which is the alkane. It's the first family that we're dealing with here. It is the alkane. Now, let's look at the structural formula of this alkane here. The structural formula, we are going to have 2 carbon atoms, okay? Because remember, the word if, the prefix there, means 2 carbon atoms. Let us draw the structure of this carbon atom. So it's going to be 1, 2. So this is the structural formula, okay? It must have a maximum of how many bonds? 4. Each carbon must have a maximum of 4 bonds. So here I'm having 1. Let us add. On the first carbon, I'm having 1 bond. This is going to be the second, third, fourth. Okay. How about the second? On the second carbon, I'm going to have 1 bond, second bond, fourth bond. Now I put my hydrogen atoms. So let's put the hydrogen atoms. Put the hydrogen atoms around the carbon atoms. So this here is our ethane. Eth means 2 carbons. Okay, let's go to the third example. In propane, prop means 3 carbon atoms, right? That's what it tells us, prop. Okay, let's do the same here. So prop, that is the prefix, right? Prop, prefix is prop. So prop means how many carbon atoms? It means 3 carbon atoms. Let's draw the structural formula. We know the ANE tells us what? What does the ANE tells us, guys? It tells us that this is an alkane. Remember, we are starting with the alkanes. So the ANE tells us that this is an alkane. Now let's put the bonds. The first carbon atom is going to have the first hydrogen. Now we are having how many bonds? 1, 2. I must have 4. So I'm left with 2 bonds. Second bond. Now let's go to the second carbon. I'm having how many bonds here? 1, 2. So the second carbon has 2 bonds. And then let's put the third bond. Now the second carbon is satisfied. It is now having a maximum of 4 bonds. How about the last carbon, the third carbon? 1. Then I will need the second one. Let's put the third one there. Then that there is going to be the fourth one. Can you see, learners? That's how we draw the structural formula. So here we are looking at the structural formula. Okay, so let me tick this. Let me tick this in pink. Okay, we're going to be looking at the structural formula. We are also, I think we've also looked at the functional group, that this is the carbon single bonds. All right, and then we have looked at the general formula. We have looked at that, okay, on the alkanes, and then we have looked at the prefix and the suffix. All right, and the name, the IUPAC name. So these are the IUPAC names. So this here, methane, ethane, and propane. These are your IUPAC names. So from the methane, ethane, propane, butane, up until octane. Now let's look at the fourth IUPAC name. Fourth IUPAC name here is going to be butane, right? Because remember, we started from meth, now we're going to eth, then we went to prop, now we are on but. All right, so let's look at butane. Let's look at butane here. And but, remember, if you can recall, we know that in the previous lesson we said but means 4 carbons, right? So this here means a maximum of 4 carbon atoms. The fourth one. These here, from methane, ethane, propane, up until butane, these are our IUPAC name. And always remember that the ANE, the last part there, the ANE tells us of the alkanes. All right, the alkanes will always end with the ANE. All right, that's very important. All right, guys. If you wanna see what the general formula means, the CnH2n plus 2. If you want to see what it means, the N, the Cn, can you see that sub N there on the carbon atom? N means the number of carbons. So let's look at methane. So let's look at the molecular formula. If you write the molecular formula, you're gonna see that we have got 1 carbon atom. You've got only 1 carbon atom. So you have C1. All right, that is methane. You've got only 1 carbon atom, and then the 2 there on the H2n. Can you see the 2n there? The 2 means on the carbon, on the first carbon, on the carbon there, up and down, you have 2 carbons. All right, let's look at ethane again. Let's look at the second part, the ethane. Can you see this carbon up and down, we have 2 hydrogen atoms. The second carbon up and down, we have 2 hydrogen atoms. Can you see that, guys? So this 2 here means that we have 2 hydrogen atoms up and down. Okay, up and down of the carbon atom. Okay, up and down of the carbon atom. Same applies to propane. Look at the first carbon, up and down, we've got the 2 hydrogen atoms. Up and down here, 2 hydrogen atoms. Up and down here, 2 hydrogen atoms. Same will apply there. Same will apply on butane, right? Yes, same will apply on butane. Same will apply there. But then let's look at the last 2. Can you see the plus 2 there? The plus 2 means that on the ends, on the far end, we have got 1 and 2. Can you see this? 1, 2. Look at the methane. 1, 2. That is the plus 2. So the carbon has 2 hydrogen atoms up and down, but on the sides, on the far ends, on the sides, we have got 1, 2. 2. That's what the plus 2 means. All right, let's look at the ethane. The ethane, on the sides again, we have 1, 2 hydrogen atoms. Let's look at propane. 1, 2 hydrogen atoms on the sides. Let's look at butane. 1, 2 hydrogen atoms on the side. So that is the meaning of the general formula CnH2n plus 2. That's how you're going to memorize this general formula. If you understand what it means, then in the exam you will be able to you will be able to remember it or to recall it. Okay, so that's very important, guys. Now let's move on to the fifth one. Right, let's move on to the fifth one. I'm going to erase here so that I have some sufficient space. Now guys, let's look at the fifth carbon. Now the fifth carbon here, the fifth carbon will have 5 carbon atoms. Right, this is going to be the fifth carbon. The fifth carbon is going to be pentane. Pent means 5. All right, remember. So from pentane here we go to hexane, right? Hexane, hex means 6 carbon atoms, and you know the Ne means we're dealing with the alkane, and it continues to heptane. Hept means 7 carbon atoms. All right, there we have written it. Always put your hydrogen atoms, guys. Make sure that each and every carbon is satisfied with 4 bonds around it. And then let's look at the eighth carbon. Right, now we know that it has 8 carbon atoms, and it's going to be octane. Oct, that prefix means 8. All right, that's what it means. It means 8 carbon atoms. All right, it means it's 8 carbon atoms. And the Ane, we know that the Ane means what? An alkane. And we continue putting the what? The hydrogen atoms here. We continue putting the hydrogen atoms. So we continue putting the hydrogen atoms here. So that's what we're having, guys. So it is from methane up until octane. All right, in grade 12 you're going to do from methane up until octane, but you can continue up until nano. Nano means 9. Up until maybe 10 or 12 carbon. That's not necessary. We're only gonna end at the octane. Keep in mind that the general formula, the N on the C, the Cn, that N there means the number of carbons. So in pentane, we know that we're having how many carbon atoms here? Pent means 5, right? So it's going to be C5. That's what we're having, right? And then H2N. Remember, the 2 means that the carbon, this carbon has 2 hydrogen, top and bottom. So 2 hydrogen, top and bottom. This carbon also here, right? 2 hydrogens, top and bottom. And this carbon here, top and bottom 2 hydrogens, top and bottom 2 hydrogens, and top and bottom 2 hydrogens. Okay, and then on the sides we know that is we're having a hydrogen, 2 hydrogen. That is a plus 2, right? Plus 2 meaning that on the sides, all right, on the sides, on the far right, on the far left, we're having the hydrogen atoms, 2 hydrogen atoms. How many carbon atoms are we having? 5 carbon atoms. But then how many hydrogen? So it's going to be 2 times 5. That's going to be 10, right? So that's going to be H. Remember, the N means the carbon, the number of carbons, right? So it's going to be 2 times 5 carbons. That's going to be 10. So that is the molecular formula. So that's going to be 10. Remember, 10 plus 2, that's going to be 12, right? So that is the molecular formula, C5H12. Let's look at hexane. Hexane, how many carbon atoms are we having? 6, right? So it's 6 carbons, C6. And then we are going to say 2 times 6. All right, plus 2. All right, remember the N there. The N means number of carbons. So 2 times 6 plus 2. So that's 12 plus 2. That's 14. So it's H14. Okay, that is the molecular formula, right? On the heptane also, same thing. So it's C7, all right, because there are 7 carbon atoms, C7. And how many? And then we're going to multiply 7 times 2. That's 14. 14 plus 2, that's 16. So it's H16. 16, and then 8 hydrogen atoms, so it's 8 carbon atoms, C8, right? Then H, that's gonna be 8 times 2 because of the 2N, right? 8 times 2, and then plus 2, that 2 there. So 8 times 2, we know that's 16. 16 plus 2, that's gonna be 18. Can you see that this is a pattern here from C5H12? 12, 14, 16, 18. This is an arithmetic sequence. If you are doing math, you're gonna know the arithmetic sequence that has the common difference, the same common difference, which is 2. 14 minus 12, that's 2. 16 minus 14, that's 2. 18 minus 16, That's 2. All right, so here it forms an arithmetic sequence. All right, that's what we have there, guys. Now, just a little important side note on why do we use these compounds. What are the functions of these compounds that we have formed here? The pentane, the hexane, the heptane, and the octane. These organic molecules, the alkanes. All right, what are the alkanes important for? What are they used for? You can ask yourself that. So we want to know that. All right, what is it that makes alkanes useful? This homologous series, what is the importance of this homologous series alkane? So we use the alkanes as fuel. So I'm going to indicate this on top here. So they are used as fuels. Right? Meaning that the biggest use for us as human beings, we burn them, right? That's what it means. It means that we burn them. And when we burn them, it is through the process of combustion. Now, the process of combustion, we're going to look at it in the next lessons when we are dealing with the organic reactions, all right? So we burn them in the process of combustion. So for the sake of your interest, you must know that butane, the one we did in the previous slide, the main function of butane is used in the cigarette lighters. You see the cigarette lighters that people use to light their cigarettes? That is butane, all right? So butane will be burning there in order to produce that light. And if you look at hexane, the one that has 6 carbon atoms, we get the small amount in the petrol, okay? When they produce petrol, there is a small amount of hexane. And octane, the 8 carbons, is the main component in the petrol, okay? The petrol that is used for cars, all right? It is the main component. And propane, the one that has 3 carbon atoms, is the one that we burn, you know, the gas, the typical gas that we use. So let's say you are using the gas stove. That gas there is the one that is burned. That is propane, okay? That is propane that is used there. So in a nutshell, the alkanes are used for petroleum, for the fuels, that is petrol and diesel. So we burn them in order to use them, all right, as human beings in our everyday life. So in the next lesson, we are now going to be looking at the alkenes, okay? We are going to be looking at the alkenes. We are done with the alkanes. That will be the 3rd lesson, okay? And thank you for watching. Bye-bye.